All right. How'd you guys like that intro? Okay, so I'm going to be studying some physics here, and I'm working on magnetic forces and magnetic fields. So I'm just going to be working through these slides. I'm not really expecting anyone to actually watch this stream. I'm just doing it because I'm bored. All right, so we're going to start on this problem here. Okay, so the solar wind is a thin, hot gas given off by the sun. Charged particles in this gas enter the magnetic field of the Earth and can experience a magnetic force. Right, and for charges to experience a magnetic force, the velocity has to be perpendicular to the magnetic force. And what's the other thing? Has to be perpendicular, and I'm pretty sure I wrote it down somewhere. And the charge must be moving. Okay. So if there's a charged particle traveling with a speed of 9, okay. So hopefully this is actually recording. Yeah. Okay, so we know that the formula is F equals QVB. F equals QVB, QVB sine theta. And so we know B, we know V, and we know the charge of an electron and the charge of a proton. So we need to know the radius of the circular path on which the particle would move if it were an electron. Okay, so how do we find that? I'm trying to think this through, and I literally don't know, so I'm gonna look it up. Okay, so the magnetic force is given by QVB. We got that. We got that. Okay. Force centripetal equals 1/2 mv squared. Or no, mv squared over r. Okay, that's right. All right, I know exactly what to do. So it's going to be like F equals QVB sine theta. So we're going to find the force for an electron and for a proton. So the charge for both is going to be the same. So it's going to be 6.0 times 10 to the negative 19, I think. What is the charge of an electron? 1.602 times 10 to the negative 19. 1.602 times 10 to the negative 19. So if we go F equals 1.602 times 10 to the negative 19 coulombs times the velocity, 9.0 times 10 to the 6 meters per second, times the magnetic field, which is 1.2 times 10 to the negative 7 Tesla. 1.602 times 10 to the negative 19 times 9 times 10 to the, what was it? To the 6. 9 times 10 to the 6 times 1.2 times 10 to the negative 7. Okay, so that gives us a force, which is 1.73 times 10 to the negative 19 newtons. So now we know the force. And so if the force centripetal is equal to the magnetic force, then magnetic force is equal to mass times velocity squared over radius, and we're going to solve for the radius. So R equals mv squared divided by the force. So now we just need to know mass of a proton and the mass of a electron. Okay, what is the mass of a proton versus an electron? Okay, what is that? 1.67 times 10 to the negative 67 kilograms. So it's going to be R equals 1.67 times 10 to the negative 27 kilograms. And 9.1 times 10 to the negative 31. It's 10 to the negative 31. So we're going to go 1.67 times 10 to the negative 27. 1.67 times 10 to the negative 27 times the velocity, which is 9 times 10 to the 6 squared divided by the force, which is 1.73 times 10 to the negative 19. So that means that we should have, if we did this right, we should have a radius for the proton. The radius for a proton should be 7.82 times 10 to the 1, 2, 3, 4, 5. And the radius for an electron should be 9.1 times 10 to the negative 31 times the velocity squared divided by 1.73 times 10 to the negative 19. So that should be 426 meters. All right, let's see if we got that right. We did not get that right. Okay, so we did that right. Times. Oh, that's why. Okay, yeah, we did get it right. We're good. should be divided by the force, which is McDonald's, Kentucky Fried Chicken, and a Pizza Hut. Q, V, velocity cancels out. So we did that. Okay, so conceptual example for particle tracks in bubble chamber. The figure shows the bubble chamber tracks from an event that begins at point A. At this point, a gamma ray travels in from the left, spontaneously transforms into two charged particles, particle 1 and particle 2. These particles move away from point A, producing two spiral tracks. The third charged particle is knocked out of the hydrogen atom and moves forward, producing a long track. The magnitude field is directed out of the paper. Determine the sign of each particle. If the magnetic field is directed out of the paper, which means that it should be like that. That's the end of the paper. Determine the sign on each particle and measure the particle. And which particle is moving most rapidly? Okay, so on particle 1, it's going out of the page, moving like that. So the force is upwards. So particle 1 moves upwards. Particle 2 out of the page. Downwards. So it moves left. Okay, that's right. So the first one goes upwards out of the page. So that means particle 1 has a negative, and particle 2 is positive. Particle 3 is neutral. Particle 3 is neutral. And which particle is moving most rapidly, assuming that each particle has the same mass? Well, if we want to figure that out, we go force centripetal equals mv squared over r. And assuming they have the same mass. It's the same mass. Huh. So they both have. No, this one has a bigger radius. Particle 2 has a bigger radius, which means that particle 2 would also be moving the fastest, because the force centripetal times the radius is directly proportional to the velocity. So the greater the radius, the greater the velocity, and also the greater the centripetal force, the greater the velocity. And the centripetal force is equal to QVB. They both have the same magnetic field. They both have the same magnetic field. So they both have the same magnetic field, both have this different velocities, and Q, V, B. Yeah. So let's see if we got it right here. Let's see if we got it right. Whoops. Okay, so the question was conceptual example 4. Oh, they didn't even add an answer. Okay, so therefore particle 1 will be a negatively charged. We got that correct. Particle 2, positively charged, correct. Particle 3 could be a high energy electron. What does that mean? As it's slightly deflected upwards but moves in circle with large radius due to its high velocity. I don't know what that means, man. Okay. Oh, I didn't even consider particle 3 for the last part of the answer. Which one could be moving the fastest? I think it'd be particle 3 because the radius is. Would it be considered infinite? It'd be really nice if my professor provided the answers. To the frickin' worksheets, but he doesn't. Okay, I guess they don't answer it. spirals for both particle 1 and 3 are both counterclockwise, while the spiral for particle 2 is clockwise. These facts suggest that particles 1 and 3 would have the same sign. Okay, so this actually is moving in a circular path. So that means particle 3 should have the particle 3 should have the greatest velocity, and particle 3 should also be negatively charged, along with particle 1. Okay, no one's answered the second part of the question still. That's nice, that's nice. I guess I'll never get an answer to this question, unfortunately. Unless so I said negative, positive, negative, negative, positive, negative. So B. So A, C, and D should be incorrect. Yep. And all right, I'm just gonna trust that I was correct for the second part. Okay, so a particle of charge 7.30 microcoulombs and a mass of 3.80 times 10 to the negative 8 kilograms is traveling perpendicular to a 1.60 Tesla magnetic field, as the drawing shows. It does indeed show that. The speed of the particle is 44 meters per second. What is the value of the angle theta such that the particle's subsequent path will intersect the y-axis at the greatest possible value of y? Okay. So we know that the particle's charge is 7.30 times 10 to the negative 6 coulombs. We know that its mass is 3.80 times 10 to the negative 8 kilograms. We know that the magnetic field is equal to 1.60 Tesla. And we know the speed of the particle is 44 meters per second. So we want to find the angle of theta. So we also know that the force of the magnetic field is equal to the charge times the velocity times the field times the sine of theta. So to find sine of theta, you have to divide the magnetic force divided by Q, V, and B. So we can find the force by equating the centripetal force to the magnitude of the force. So magnitude of the force is equal to mass times velocity squared. Over the radius. The part of subsequent path will intersect the y-axis at the greatest possible value. It's going into the page. Velocity is pointing that way. So the force is upwards like that. So the y-axis at the greatest possible value. Y max equals 2 times R. From the drawing above, it can be seen that the largest value of y is equal to the diameter. It's equal to the diameter. My brain is not cooperating. It's to wake up. The maximum value of y is twice the radius of this circle. Okay, so I see what they did here. They're solving for y and for r. It's twice the radius of the circle. Why is that? I'm confused. I'm confused. So the particle is directed outwards. And I know it's into the page. The velocity is this way. So the force should be this way. Is the particle going to rotate like that? I guess if it does, then you're going to get the y value from, you're going to get the y value. Okay, yeah, that it makes complete sense now. So it makes a full circle. So it's going to be the radius on this side. And then when it does a 360 or not 360, a 180, then it's going to be plus the radius on that side. So that makes sense. So that means it's going to be radius is equal to mv squared divided by qvb sine of theta. Cancel out the v's, so it equals mv over qb sine theta. What is the value of the angle theta supposed to intersect the y-axis? Okay, now I'm confused because when we're solving for the radius and we're dividing the mass times the velocity by the charge, by the magnetic field, and then by the sine of theta, I'm not sure what the value for sine. Do I just put 90? Let's see. It would be the opposite over the hypotenuse. But we're just finding the vertical component of the velocity, so it should just be okay. Okay, so we're just finding the vertical component of the velocity. So I'm assuming okay, here, when the particle passes through the coordinate origin, its velocity must be parallel to the x-axis. When the particle passes through the coordinate origin, its velocity must be parallel to the x-axis. Okay, I see. So, when it's at the greatest possible value of y, then the velocity is going to lie. It's going to be traveling at a 0-degree angle along the x-axis. Okay, I completely get it now, I think. Because it's going to be traveling completely along the, even if it's not traveling along the x-axis, if it's traveling at an angle as well, like it is in this picture, then I should still cancel out because there's no change in right? So if we go to mass, which is 3.80 times 10 to the negative 8, times the velocity, which is 44, divided by the charge, which is 6.02 times 10 to the negative 19, times the magnetic field, which is 1.60 Tesla. We get 1.74 times 10 to the 12. And that is the radius, so meters. And then we multiply that by 2. So it equals 3.47 times 10 to the 12 meters. But then it's asking for the what's the sign of 0? 0. I'm going to read another answer to see if I can get a better understanding of this. If anyone's actually watching the stream, you should speak so that I know. Okay, so data from the question is blah, blah, blah. Can't tell if that's right. And they're out. Click on a comment to show it on the screen. How do I put it back? All right, so we're going to finish this question here. Sometimes even if you don't, if the result for a Chegg answer doesn't show up on Google, if you just paste it in Chegg, then it'll show up. Like this, yeah. Okay, so y max equals 2r to get that. For y to be maximum, theta must be 0. You don't get that part. For y to be maximum, theta must have to be 0. okay, so like from my understanding here, the reason why the maximum value of y is twice the radius because, well, particles can be traveling in a circular motion counterclockwise. And so for it to reach, and so it's the maximum distance that it can travel from the origin is going to be the distance right here plus the distance right here. What I'm confused about is why the angle has to be 0 for it to be the maximum. Oh, wait, no. Because
What's cos of 0? Such a bezel intersect the y-axis at the greatest possible value of y.
The greatest possible value. Probably shouldn't be drinking right now. It makes me very anxious.
Radius equals mass times
velocity. We know that a magnetic force of charged particles in light years is that. For Q is the charge, V is the time of velocity, D is applied to magnetic field of the ball. This magnetic field is perpendicular to the velocity. Since the magnetic field is perpendicular to the velocity, difference theta is 90 degrees. The above equation then becomes blah blah blah, is blah blah blah. Okay, so this is the question. We're gonna go back down here. We are going to, honestly, I'm considering restarting the stream.